We're going to multiple integrals, which is why we're starting with Riemann sum. When you start with a Riemann sum, we're going to start with the limit with the summation, which we always do, but we're just going to add another one, and we're going to create a box. We're going to get the box as our boundary, and we're going to get the function up top and getting the area volume of it. That's what we do. Fun fact that you can actually get area, but in reality, it's not really area. The reason you get area is because if you get unit, if the unit doesn't matter, what happens is that you get x and y, and x and y is meter square, and without the function of x and y, you get area. And it's kind of weird. It's not really that weird. It's just if you have 1 meters as our function, let's just say 1 meters and not unitless. What happens is that it would get the same number, but the unit would be meters square and meters cube over here. And what happens is that it really just doesn't matter. If it doesn't matter, it'll be the same function, same number. That's what I meant to say. We'll see that more later on. I'll show what I mean. Volume average is just this. It's not really anything special. Then we have R, which is A, B, C, D, and creating a box. Not my favorite denotation of how to get A, B, C, D, and the bounds. You see what I like to show as my denotation. It makes more sense in my eyes. And then we have a separation over here, but I'm still a student, so I might be wrong about that. If you have a weird case where you can separate all the x with the y, then you can do the integral separately and multiply each other. It doesn't happen that often. I mean, it can. Actually, it's polynomial, so it probably will. Actually, take that back. Then we have the more boundary. I'll just show you. It's much easier than doing these philosophical things. Then we have the indefinite integrals, basic shenanigans, and we start doing the actual integrals. So here we start with z is assumed to be meters square. So whatever this spits out is meters square, but integral gives you meters 4 because each integral adds a meters to it if you're talking about xy plane as x and y as meters. If you have a function like meters in time, then obviously it'll be different. But right now, then that would be meters multiplied by t. Actually, I don't like it. You're right. That's so right. Actually, I shouldn't have this because thinking about it, those will actually be more confusing later on. So I should delete that. Because whatever you have, it'll change depending on the need of the question, physical question. If it was x z and then we had time over here, then obviously if you're going to integrate by time over here and integrate by x over here, then you have a meters and time. So you're going to have, if your original function was in meters squared, that would be meters cubed with multiplied by time. So it wouldn't be something that I should put down here. So I'm going to actually delete all this. Good catch. So over here, obviously it got cut off. I will show off all the different functions I have used. Let me see over here. It's getting dark in here, so maybe it's like 11. It's almost 12 o'clock p.m. a.m. I don't know. It's like 11:57 p.m. So it might be a little hard to see which one. Is it that one? No. Is it this one? Yes. Here's this one. So you can kind of see how I did it. Just this box over here is what we're looking at. Then below this, so you can kind of see the box over here, which creates the area we're looking for. So that's what happened here. We're just getting the area of that. Does that make sense? It's a coincidence that it turned to 1. It's not really. I just chose those points at random and apparently it turned to 1, which good for me. Made my life easier. Unlike this one, which turns to 7.7584 with this weird equation over here. But this time we get a line over here. So as you can see by the visual over here, it got cut off. Why it got cut off is because it takes forever to go up to that line, because I didn't realize until I actually done it that it takes forever to go there. But as you can see, you can kind of see the line over here and the stop over here. So these come in pairs. So if you get the integral like this, a double integral like this integral and this integral defines a region already. So basically, if you change, you can't change one without changing the other. You'll see what I mean by the next one over here, and this one just a little. I don't know why I put that there. Actually, I think it's a brain break. I don't know. This one over here where we change from dx dy to dy dx by changing the bounds. As you can see over here, we'll see. Do let me go over here and figure out which one was it. This visual. You can kind of see over here what happened. If it doesn't really make sense, then I'm gonna have to explain it either way. So if you're doing a dx dy, we're first going like this over here. So we can kind of see that. Wait, am I correct about this? Yeah, no, yes, no. 2x. No, I'm wrong. I'm wrong. So first of all, the top one, the dx dy, the dy ends over here. So the line is like this, where we start at 1 and end at y divided by 2. When we go change over here, we're going latitude over here this way, where you get 2x on the top and 0 on the bottom, and then that builds our boundary domain. And then let me delete this because this, I just realized is bad, so we'll delete that. And with that, we'll go to the next question. Over here, this is y squared, which kind of makes sense. If it doesn't make sense, oh well. What we have here is that we are going to delete this. I don't know why we did that. I know why. I was a fool. um, and then we get this kind of real shape. I believe I have that over here. Is it this one? No. It's one of these. It'll come to me. Which one ever it is. Is it this one? No, that's the other one. Did I accidentally delete it? It might have been accidentally deleted. I don't really see it. So, oh well. If I accidentally deleted it, I forgot to save it, which caused that effect. Oh well. Uh, well, that happened. All right, let's go over here and show off what we get. And the most important part about this is the change over here, where this question turned to this question. But as you can see, it doesn't matter 0, 1, 0, 1. So, and then we get the same answer over here. We still get the same. I didn't show all the steps, but it's the same as this because we know the bounds, the area doesn't really matter which way you do it. Over here we have the points and how we can get. We did the y direction. We can decompose it, but as you can see from the next question over here, not this one over here, decomposing it cause a lot of problems. We want to get rid of this problem where we do a bunch of integrals like this. So to get rid of that, we did the y direction. Those are different questions, but as you see, if you did decompose them, it'll cost a lot of new steps or numerical processes. I don't know. Analytically process, I guess. Anyway, we get these three shapes. I think I have all those visuals. If this thing would work. I think it's vision 4. On the dash. I don't know why. Over here we have a visual. We see how I did it. And then we get these. So clearly you can kind of see what I did. We made lines over here, and we did this line divided minus this line to create that region over there. And no one likes algebra, but you have to know how to do algebra here. So it was a pain in the ass for me to do it. I didn't like it either. No one likes this algebra process, I don't think, unless you're an algebra lover, which I don't think there's. I mean, you love algebra, but you don't like to do it. You don't like to do all the algebra out, which is why I don't like doing this. That was a pain in the ass. Okay. Anyway, we get this. We are starting to do 3D integrals. I mean, not 3D, like triple integrals, where we do triple integrals. Where the first thing I'm doing is changing the minus c something integral into a 3D integrals like this. Not this one over here. But the actual practical reason probably has to do with something with density, something with temperature, something with pressure, something with water fluids, something with continuous flow where the mass is the same but the flow inside of it is different, something like that, where integrals might matter. Here's a pain in the ass one, and then we start with the Jacobian matrix, where we get R, and we start with the Gaussian distribution because why not? Everyone loves Gaussian, right? Not really, everyone hates it, but it's the most important integral that everyone talks about in statistics. So I put it in there, and then I start doing the cylinder stuff because this was a pain in the ass question. What happened was I need to double check it with a visual, not that visual. Well, I didn't trust my math basically. Even though I plugged it into a calculator, it got set 22.7555. I didn't trust it, so I did some plane creation, and if I cut in half, the area had to be 20 less than 25.12327, and it was less than, so I then believed it. So I created this plane, and I created the regions, and then um, made sure that the area was less than that, so that it's true. And it turned out it was correct pretty much. So I believe in my math. So yeah, and then that's still all I did. I need to do line integrals, I need to do vectors, and I need differential equation. I think I did most of differential equations done. Linear algebra, I am probably gonna try to ditch that as soon as I mean, I don't like, as you can see, I don't really like to do linear algebra because it's a lot of true and false questions. It wasn't hard. The concept was very easy. The matrices were very easy, but the part about linear algebra I didn't like is that it was mostly true and false questions, and it makes sense because there's a lot of topics and you want to compress it all. So I think the professor just said, let's do all of these in true and false questions, and then dump it into our heads, and then make sure we know most of the content. I didn't like that method, but that's how I learned the linear algebra. So I'm just like, I don't want to do it. I don't want to do it. I'll do it last. I don't want to do it. So that's what I've been doing with linear algebra. I'll do all through the textbook. Anyway, with that said, I'm done. Yay.